example is a level 2 example. Now read and understand problem. In this, a uniform beam PQ of mass 20 kilograms and length 3 meters is smoothly hinged to a vertical wall at P. Then one end of a light rope is connected to the other end Q of the rod, and the other end of the rope is connected to a point S of the wall vertically above P. The length of PS is √3 meters. This is in equilibrium with PQ horizontal. In the part A of the problem, we are asked to find the tension in the rope first. Let this angle be theta. That is PQS. Angle PQS is theta. Let the tension in the rope be T. It acts towards this direction. Then there's from S, the tension is in this direction, acts in this direction. When I produce this line, it meets the rope at H. Now, how many forces are acting on this? This is one, weight and tension, and there's another force, that is the reaction at the hinge. Then this is in equilibrium under the action of 3 forces. The forces are not parallel. If the forces are not parallel, the 3 forces must meet at a point. Let this reaction be R. Then R must pass through H. That is, these 3 forces meet at a point. That point is H. This angle is theta. What is tan theta? This is a right angle triangle. Tan theta is √3 divided by, tan theta equals, this length is √3. √3 divided by, this is 3 meters. 3. Then we get 1 over √3. Tan theta is 1 over √3. Now we know tan 30 is 1 over √3. So theta equals 30 degrees. Now these 3 forces are in equilibrium. So we can write algebraic sum of the moments of the forces about any point in the plane is equal to 0. We can take moments about P. We take this direction as the positive direction. Then what is the moment of T about P? This is the tension is in this direction. The moment of T about P is equal to T product of T into the perpendicular distance from P to this line. If we draw a perpendicular from P to this line, this perpendicular distance equals 3 sine theta. What is the moment of this weight? That is 20g. This is in newtons. 20g newtons. The moment of this force about P is in clockwise direction. That is in this direction. So it is minus, that is 20g into the length of the perpendicular from P to this line. That is this one, from here to here, because this is 90 degrees. That is equal to 1.5. Because the length of PQ is 3 meters. From here to here it is 1.5 meters. Now we equate this algebraic sum of the moments to 0. That is one condition. Now what is this? This is equal to 3t sine theta. Theta is 30. No? Then this is equal to 3t sine 30. Sine 30 minus 20g into 1.5. 1.5 equals 0. Now sine 30 equals 1 over 2. this equal to this minus 20g. 20g into 1.5. This equal to 0. This equal to 0. Now take this to the right hand side of the equal sign. Then we get 3t equals, we multiply this by 2. 3t equals 20g. 20g into 1.5 into 2 is 3. Therefore, t equals, this cancels out, t equals 20g. 20g newtons. We have done the part A of the question. In the part B, we are asked to find out the magnitude and the direction of the reaction at the hinge P. Reaction at P is R. Let the horizontal component of R is X and vertical component is Y. These two are perpendicular to each other, X and Y. Let this angle be beta. Now, as this is in equilibrium, the algebraic sum of the component of the forces in this direction equals 0. Now, what is the component of this force along this direction? That is x. That is x. X minus t is in this way. When I resolve this in this direction, it is t cos 30. This say t cos 30. In this direction, it is minus t cos 30. This equals to 0. So, x equals t cos 30. But t equals 20g. 20g. What is cos 30? Sin 6. That is root 3 over 2. That is 10g root 3. That is x equals 10 root 3g. Then the resolved parts of the forces along this direction, that is vertical direction, is also 0. Algebraic sum of the resolved parts of the forces along vertical direction is also 0. What is the resolved part of R in this direction? That is y. When we resolve t in the vertical direction, that is t sin 30. Y plus t sin 30 minus 20g. Minus 20g equals 0. From this, we can write y equals 20g. We take this to the other side, then it is 20g minus t sin 30. What is t? T is also equals to 20g. 20g into sin 30, that is 102. 2 cancels with this, then we get 10 here. This is 10g. That is y equals 20g minus 10g, that is 10g. Y equals 10g. Now r squared equals, what is r squared? R squared equals x squared plus y squared. X squared plus y squared. X is 10 root 3g. Then we get 10 root 3g squared plus y squared. That is 10g squared. When we square this, we get 300g squared. 300g squared plus 100g squared. 100g squared. That is 400g squared. R squared equals 400g squared. So, R equals square root of this. That is 20G. R equals 20G newtons. I have found out the magnitude of R, that is 20G. Now we have to find the direction of R. Let this angle be beta. That is GPH. Angle GPH equals beta. Now G is the midpoint of PQ and GH is drawn parallel to PS. Then GH, from geometry, GH equals half of PS. That is, this is root 3, then GH equals root 3 by 2. Let GH be Y. Therefore, Y equals half of this, that is root 3 by 2. Now it is tan beta. That is, tan beta equals Y divided by 1.5. That is, tan beta equals root 3 by 2 divided by 1.5. Root 3 by 2 divided by 1.5. This is equal to root 3 by 3. That is, 2 into 1.5 is 3. This is equal to 1 over root 3. That is tan beta. Tan beta equals 1 over root 3. Then what is beta? Therefore, beta equals 30 degrees. This angle equals 30 degrees. Then we know the direction of R. Now, for the last part of the problem, we have to draw another diagram. Now the rope is removed and the beam is held in equilibrium in horizontal position by a light rod KG, where G is the midpoint of the beam. This angle PKG equals 60 degrees. 60. Then there's a thrust in this light rod. Then the beam is supported by this thrust. Let that be T1, thrust T1. Now there are two ways of solving that part. One is this. Now this beam is in equilibrium by the action of three forces. What are three forces? One is the weight, other is thrust this way, and the other force is the reaction at the hinge. We don't know the direction, but since this is in equilibrium by the action of three forces which are not parallel, the three forces must meet at a point. That is, the reaction also pass through G. This is the first method. Three forces keep the beam in equilibrium. Since the forces are not parallel, the three forces must meet at a point. That point is G. So the reaction starts from here and passes through G. That is, reaction is horizontal direction. So the reaction is in this direction, in the direction PG. Now this is the second method. Let the vertical component of the reaction be Y and horizontal component of the reaction be X, as shown in the figure. Resolving vertically, you can write y1 plus T1 cos 60 plus T1 cos 60. That is when we resolve this in along this direction. That is T1 cos 60 minus 20G equals 0. Therefore, y1 equals 20G minus T1 cos 60, T1 by 2. Now we have to take the moments about P. What is this this length? PG equals 1.5. Is 1.5. Now, what is the moment of T1 about P? That is T1 into this perpendicular distance. That is, this is 1.5, this is 30, this is 1.5 sine 30. Now, what is the moment of this one, this force? 20G into 1.5, that is this way. That is minus 20G into 1.5. Now take moments about P. That is the algebraic sum of the moments of the forces in this direction, that is anticlockwise direction. We equate that to 0. Then what is the moment of this T1 about P? T1 into perpendicular from a distance from P to this line. That is, if we draw a perpendicular, then that distance, that length, what is that perpendicular distance? PG is 1.5 meters. This angle is 30. Because this is 60, this angle is 30. Then this perpendicular distance is 1.5 sine 30. Then that is equal to T1 into 1.5 sine 30. Sine 30 is 102, that is, the moment is T1 into 1.5 into half. That is the moment of this. What is the moment of 20g? The moment of 20g is 20g into this length. That is, this length is g. This is 1.5 meters. That is minus 20g into 1.5. This equals to 0. We can cancel this 1.5 and we get T1 divided by 2 equals 20g. Therefore, T1 equals 40g. Newton. Then other equation we can write is this: algebraic sum of the resolved parts of the forces along this direction equals 0. Then we begin with this x1 minus T1, this is 30, this angle is 30, T1 cos 30. x1 minus T1 cos 30 equals 0. These two forces won't come. This is equal to 0. Therefore, x1 equals T1 cos 30. T1 is 40g. 40g cos 30 is root 3 over 2. We get x1 equals 20 root 3g newtons. Now to find out y1, we substitute this one. T1 equals 40g in the equation 1. Then we get y1 equals 20g. We take this to the other side, minus T1 cos 60. T1 is 40g. 40g cos 60 is 1 over 2. Then we get this cancels with this and we get 20g. Then y1 equals 0. Y1 is 0. x1 is 20 root 3g. That is positive direction is this one, x1. The reaction is horizontal because this is equal to 0. The reaction is horizontal. In the first method, I marked R1 in this direction, but that is not in that direction. R is in this direction, but line of action of R passed through G.